Alright guys, welcome to RC Mojo. This week we're going to add some sound to the Tamiya 1850l using one of my boards to do all the fun stuff. One of the useful things with having the box truck is the box itself. Not only is it a great place to fit the electronics, but to me it looks like an almost ready-made speaker enclosure. First job then is to take the top off the box. We need to remove the 4 screws that attach the corner bits to the uprights. They just unthread, then we can lift off the top. To access the gubbins inside, we need to slide up the side panels. It couldn't be much easier. Inside we find the quick basic install I did just to get the truck up and running. We will be keeping most of it as it is, but we will be replacing the light controller. Currently it's got one of the mini boards. It does headlights, brake tail, reverse lights, among other things, but we want more features along with sound for this truck, so it's going to have to come out. To replace it, we've got a Revision B advanced light controller. Eventually, a descendant of it will be up for sale. Now, at the time of recording the voiceover, there's actually a Revision C being tested and a Revision D in the pipe, which should be the final hardware. This Rev B will do us just fine though. It's got all the features we need and then some. Currently, there's a 3-channel receiver installed, which is actually just enough to have a working system. At some point, it will be swapped out for a 6 or an 8-channel, so we'll have independent indicator control, horn, 3-speed gearbox, etc. Unfortunately, this 8-channel is duff. It doesn't seem to reject other signals, so if there's more than a couple of 2.5 gig radios on, it drops into failsafe. Now, because I was in a rush when I installed this lot, the wires that go off to the LEDs are just soldered in place. Now, we won't be needing the mini light controller board anymore, so we can just cut them free. Now, I'm not going to go into detail about how they're wired. When the board makes it to sale, I'll put up some proper diagrams and more than likely make up a few kits just to kick things off. Right, to mount the light controller, I've made a frame and some posts that screw down to holes meant for the Tamiya electronics. Now, it's not going to go up on Thingiverse this time, of course, as it will only fit this prototype board. The next revision is actually quite a bit smaller. 3 of the posts are just hollow tubes. The 4th is a little bit different, as rather than a hole, there's a short nub for it to locate on. A bit strange, but I'm sure Tamiya had their reasons. The odd post fits to the frame first with an M3 screw, then on the bottom we stick on a bit of servo tape. I made the post just ever so slightly shorter to allow for it. Since there's no screw at the bottom, it makes it that bit more stable when plugging and unplugging things. The other 3 posts just use some long M3 screws that go through the frame, through the posts, and then screw into the electronics tray. Nice and simple, and is going to look a lot neater than just sticking the board to the side somewhere. To connect the receiver to the light controller, we've got a set of female-to-female servo leads, easily available on eBay, but the final board will come with a set, so there's no worries there. We've only got a 3-channel receiver, so we only need 3 leads, one for the steering, one for the throttle, and one for the aux channel that turns all the lights on and off. I also added an antenna tube mount to the frame, so it's not bundled up with the other wires. It looks neater and will get us the best range possible. The board now sits on top of the frame, which has spacers built in, so we just need to install 4 M3x6s in the corners. It'll be solid enough that we'll be able to reach in through the back door and pop out the SD card without having to worry about knocking something over. Everything is nice and stable. On the side of the board nearest to us, there's the pins that connect to the servo channels. Each cluster has 2 pairs of 3 pins, servo connection in and a servo connection out. We need to connect the steering channel to one of the first pair, throttle to the second, and aux to the third. Then the steering servo plugs into the pins next to the steering channel, and the ESC plugs into the pins next to the throttle channel. Now, it's worth noting there's a total of 6 channel inputs on the board, all of which can be configured for various functions in the config file on the SD card. There's no fixed order to connect things. For power, we need to connect the board to the main battery. For now, I've just made up an XT60 to XT60 tap with an inline switch. It's a bit bulky and not especially tidy, but it'll do the job for now. The version of the board currently being worked on can switch itself on and off based on whether the ESC is turned on, doing away with the extra power switch. Next then, we have the speaker. Most of the aftermarket installs use a 40 to 60mm speaker up in the roof of the cab, which does work well enough. but that's when you're limited on space. If we use the whole box as a speaker cabinet, we've got lots of extra space. And because the front panel of the box just slides out, we can easily 3D print a new one with reinforcements and the speaker mount. This one's a much bigger speaker, so it should shift a good bit more air. If it works out, we should have a bit more bass in the sound than the usual install. To install it, we just slide it in where the stock panel came from. When the sides and roof go back in, it's going to be nice and solid. To connect it, we just need to pop the wire ends into the screw terminals and nip up the screws. Now off camera, I've crimped some connectors to the LED wires. I'm not going to go into detail today with this install, but I think it's one of the easier boards to wire up. It's got 16 outputs, all of which are programmable for any function. So here I've ended up with one connector for the front lights and one connector for the rear lights. There's no teeing off, Y pieces or extra electronics involved, it's all point-to-point wiring. There's also the volume control, which is just your basic 10k pot. There's 3 pins on the board to connect to 3 pins on the pot, so it couldn't really be much easier. Having said that, the board will most likely come with something, so it will be plug and play anyway. It would now be just a case of sliding the side panels back in and screwing the roof back on, except I noticed the side panels ever so slightly rattle. Not much, but I think with the speaker going they might just buzz a bit. Then I remembered that a few years ago I got a PC case acoustic mat set. Now I used a set in a previous machine and it did the trick. In the last build though, the case I picked already had foam on all the panels, so I never used this set. It's basically just a set of fairly heavyweight sticky backed foam that's cut roughly to fit a full-size ATX tower case. It'll dampen the vibrations in the box a bit and probably reduce the high frequencies a little too, both good things. What we do then is cut some of the foam to cover the inside of the panels, remembering that we need to keep the edges clear so they can slide into the uprights. Now I'm sure if you look on eBay there's a range of sticky back acoustic foam. It shouldn't really matter what you use, we just want to dampen the vibrations a bit so it's really not very critical. Some bog standard foam padding and spray mount would more than likely be good enough too. Next we can pop the lid back on with its 4 screws. This time they're a little bit tighter to get in. I think the foam bits are just ever so slightly oversized, but that's a good thing as they're going to squeeze up, really holding the panels in place. With the 4 screws in, we can open up the back doors, pop a battery in and connect it. Switch on the light controller.
Waiting for signal.
Now it says no signal because the ESC's turned off, so the radio's off too. But if we turn it on...
Calibrating. Drive forward.
Alright, first it's looking for a stable signal to work out the centres, then it asks us to drive forward to set the throttle direction. If we blip the throttle, it finishes the setup and it's ready to go.
Calibration complete.
Another little throttle blip and the engine starts. It sounds a little bit harsh because you're hearing it through the camera's microphone. In person it does sound pretty good, certainly a lot more bass than the vast majority of trucks. In its current state we've got working brake and tail lights, reversing lights with beeper, as well as an air dump. The indicators tick-tock, and it's also worth noting that these sounds are straight bog standard 44.1 kHz 16-bit WAV files, no special encoding necessary. With the free software Audacity, you can export literally any sound you want. Looking at the front, we've got the headlights and aux lights lighting up in sequence. Using the rocker on the transmitter, we can increment and decrement through a sequence that's fully programmable. There's still some more bits and bobs to add. On the wheel arches we've got decals for the running lights and indicator repeaters, so we're going to need to drill those out and replace them with LEDs. And some running lights under the box would look pretty good too. Right, that's it for this week then. Now I'm currently working on a truck for a friend, redoing the electronics, so we might have a look at that next week. In the meantime, if you're interested in a bit more detail about the big light controller, I've written a little article up at 74hc.co.uk. It's a bit of a ramble, but some of you might find it interesting. If nothing else, there's some nice pictures. Anyway, as always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a message if there's something on your mind. Bye guys!